Hello everyone, welcome back to the class. This will be the first lecture to introduce the major topics in this class. In this note, I will give you an overview about the pavement design, including the basic concepts and the types of the pavement we will learn in this class. First, in the previous lecture, we have understand some perceptions and the reality about the pavement design. The most popular perception about pavement is like pavement are simple engineered system, but in reality, only the geometry of pavement is very simple, but everything else is very complicated. In order to conduct a good pavement, one must be knowledgeable over a wide range of the activities. For example, the most important part about pavement design is material design and selections. We have to have a good knowledge about the properties of different materials and select them carefully based on the requirements of the pavement. And second, the pavement is designed to support traffic on the road. The impact of the traffic load on the pavement should be well understood. And third, pavement is conducted outdoors, and they are affected by the environment, especially the temperature, moisture, and climate will significantly change the properties of the materials. And finally, the pavement is designed to be filled after certain periods, so it has to be maintained periodically. And the maintenance and sustainability of pavement is also an important consideration in pavement design. These are the four most important factors we have to consider in pavement design, and we will go through all of them in this class. In this note, I will first go through the basic concepts in pavement design, and then I will try to define the most common pavement types applied in reality. Here are some important variables we have to consider in pavement design. The first one is about the materials. We need to determine whether the materials is available for the pavement design in that area, and also the properties of the material and its behaviors and the different load and environment. The second one is traffic and load. We have to know how much traffic the pavement has to support, and the magnitude of the traffic, especially the magnitude of each truck, and the dynamics and the long-term loading effects. The third one is the environment. We need to consider the temperature impact, moisture, freeze soil effect, and the local climate impact to the pavement. The next thing we need to consider is the distress of the pavement. We have to evaluate different types of the distress applied to the pavement and its interaction to the variables we list on the left. Also, for the pavement, we need to think about how to construct the pavement to make it successful to support all the traffic load we designed in that area. And the maintenance and sustainability should also be considered for the pavement to last for a longer time. Finally, we need to analyze the life cycle cost and also provide the proper management about the pavement to be conducted successfully. So in summary, the objectives of pavement design is to provide a good pavement that is strong and stiff enough to support vehicle load in the designed road. And the road should be safe and it's able to provide a smooth and comfortable ride. If the pavement is not safe or the road cannot provide a smooth surface and make the ride uncomfortable, then we say that the pavement will experience functional failure. And finally, the cost of the pavement is always very important. In the pavement design, there are four types of the cost: the initial construction cost, maintenance cost, life cycle cost, and also we want the pavement to last for a longer time. It should have good sustainability. In real world, there are 5 different types of the pavement which are applied for road constructions. The first one is a flexible pavement, which will use asphalt concrete. The second one, rigid pavement, will apply Portland cement concrete. The composite pavement will apply both asphalt and Portland cement concrete. It also has layered construction with a stabilized base and subbase. In general, we will apply asphalt concrete overlay on PCC. The interlocking brick pavement is commonly applied at the roads with a low speed and a small load, such as residential area and parking lot. Finally, unpaved roads are commonly applied for the road with a very small construction budget. The composite pavements are widely applied in real world. Actually, we can say that all pavements are composite because they consist of layers of different materials bonded together. There are two types of the composite pavement. The first one is a PCC overlay on PCC, and this technology is frequently applied in Europe. In this kind of design, it will provide a cap of high-quality aggregate concrete over a thicker layer of low-quality local aggregates or recycled concrete. But this type of technology is not commonly applied in the United States or Canada. In North America, composite pavements with AC overlay on PCC are commonly applied. This type of design has a lot of advantages, such as low noise on the road, high friction, and smoothness. But the most critical issue about the AC overlay on PCC pavement is reflection cracking. This type of cracking caused by the existing joint or cracks of the PCC slabs at the bottom, and this kind of crack will extend upwards and it will show on top of the pavement. If you go to check the figure on the left, you will find a rectangle cracks on the surface, and this is exactly caused by the joint of the PCC slab at the bottom. In Ontario, we also have some standard pavement types. For flexible pavements, they apply the layered system, and depending on the depth of the asphalt surface and binder, the pavement can be categorized as the conventional and full depth pavements. The differences of these two types of flexible pavements will be introduced in the next few slides. For rigid pavements, there are two types. The first one is plain pavement. In this kind of pavement, we will put the Portland cement concrete on top of the treated subbase directly. The second one is a composite pavement. Here, we will add an additional asphalt surface on top of PCC to ensure that the pavement will have higher frictions and smoothness. The figure here shows the layer system of the flexible pavement. On top is the asphalt surface. It's very strong and durable to support a strong traffic load. Also is impermeable to resist the rainfall. The materials is manufactured, so it's very expensive in general. The depth of the surface layer varies from 75 to 200 millimeters. For conventional pavement, it's less than 150 millimeters, but for full depth pavement, it should be higher than 150 millimeters. Below the surface layer is the base layer. It's also strong and it has the property of free draining. The materials is also manufactured, but it's less expensive compared with the asphalt. Usually we apply the granule A material for base layer. The depth of base layer varies from 150 to 500 millimeters. Below is the subbase layer. It has a moderate strength, free draining. It will use the natural materials to construct the subbase layer, so it's not expensive. Usually we apply the granule B material. The depth of subbase varies from 150 to 500 millimeters. At the bottom, that's the prepared subgrade. Usually we will apply 150 millimeter compaction. This layer is relatively weak and it's moisture sensitive in situ soil, but it's not expensive. It's just the nature of soil in the foundation. All the engineered layers from the foundation up, with the subgrade being the foundation soil for pavement. From bottom up, the material gets better and the processing to material increases. In the pavement design, different layers actually have different functions to support the road. For base and sub-base cores, they provide controlled drainage to make sure that water goes away as fast as possible. They can also protect against the force action or volume change to minimize the distress caused by the environment. In addition, when the surface has to be removed, the sub-base and base can work as surface during the construction. Finally, they can increase structural capacity to make sure that the pavement can last as long as possible. While for the asphalt PCC surface, it provides a tough, smooth, and skid-resistant surface so that the ride on the road can be safe and smooth. The reason for us to introduce a layered system for flexible pavement design is actually based on the stress we estimated and the different depths on the pavement. This figure shows the stress distribution behind the surface load. We know that the surface load is the tire pressure of the car and trucks, and think about the 2 column 1 rule. With increased depths, the stress decreases dramatically. In that sense, with different layers of the flexible pavement, the stronger layers on top can shield the weaker layers at the bottom, especially the subgrade with soil foundation. In the layered system, the stiffness of different layers also have significant impact about the stress at the different depths behind the surface load. The two figures here demonstrate the impact of stiffness. The figure on the left shows a uniform loaded circular area in a 2-layered soil. The modulus elasticity of the top layer is E1 and the bottom is E2, and the depth of the top layer is H. And the figure on the right demonstrates the distribution of the vertical stress under the center line of the load at different depths. The vertical axis represents the depth from the surface, and the horizontal axis is the vertical stress. Each line in this figure represents the stress distribution with respect to the fixed ratio of the modulus of elasticity, and the curve is estimated through the Poisson solution. Here we can find that if we increase the ratio of modulus elasticity, say that we set a higher modulus elasticity for the top layer, then the stress at the bottom layer could be reduced dramatically. For example, if the ratio increase from 1 to 100, then the stress can be reduced dramatically from 0.7 to 0.1. And this reduction can release the pressure for the lower layer, so that the lower layer does not need to support very high stress. In that sense, the lower layer can sustain for longer time, and the entire pavement structure can last for a longer period, and they can perform the design function properly. Now let's see the pavement structure for conventional flexible pavement. In this kind of pavement, it contains surface and binder layers supported by granular base and sub-base layers. For the surface and binder layers, it actually contains 2 parts, the surface cores and the binder layer. Both of them are made of asphalt concrete. They're actually layered AC layer, but they have different functions. For surface cores, it's usually thin, smooth, and skid resist to support the vehicles on the road so that they can maintain smooth and safe ride. For binder layer, it has large aggregates and it's strong and rotting resistant so that it can prevent the rotting depress for the pavement and help the pavement to last for a longer time. This figure demonstrates the structure of the full-depth flexible pavement. Different from the conventional flexible pavement, which has granular base and subbase, in full-depth flexible pavement, it only contains asphalt base and asphalt surface. The depth of the asphalt base varies from 50 to 500 millimeters. For asphalt surfaces, it varies from 50 to 100 millimeters. This kind of structure usually applied in aggregate poor regions, but it's not quite common in Canada, so it's not widely implemented in Ontario either. Another type of the pavement is a long-life asphalt pavement, and actually from the name of this pavement you can see that this pavement will last for a very long time. The figure here shows the structure of the long-life asphalt pavement. On top of the pavement foundation, which include the granular base, subbase, and subgrade, there are three additional layers. The flexible bottom layer with a high fatigue resistance, the strong middle layer with rot resistance, and durable top layers. In this design, different layers will experience a different impact from traffic load. The top layer will experience a very high stress level, including the shearing stress caused by the tire of the vehicles and the truck. The middle layer will have very high compression from the top. And at the bottom layer, maximum tensile strain will be applied in order to mitigate the impact of the traffic load at different layers. For the top layer, we will introduce 40 to 75 millimeter durable materials, and at the middle layer, high modulus rot resistant materials will be applied, and the depths will be varies based on the traffic load applied for the pavement. And at the bottom layer, flexible fatigue resistant materials will be applied. The depths will be around 75 to 100 millimeters. There are some key concepts to make a successful design for the long-life asphalt pavement. First, the thin pavement at top readily cracked and rot under repeated loading of heavy traffic, so it could be replaced in the future. In thick asphalt pavements, the potential for fatigue cracking is reduced, and the pavement distress, including cracking and rotting, occurs only in the top layer, so that it will cause some damages for the top layer and won't affect the bottom layers. And when the surface distress reaches a critical level and make the top layer unable to perform the functions of the pavement, then only the top layer will be removed and replaced with new materials, so that the pavement could be maintained quickly with low cost. Here we will introduce one type of long-life pavement, perpetual pavement. The perpetual pavement is actually defined as an asphalt pavement designed and built to last for more than 50 years without requiring any major structural rehabilitation or reconstruction. It only needs some periodical renewal of the surface layer, and the maintenance may occur at every 20 years. The concept has been widely applied in Europe, and it gained a lot of attention in North America. Basically, as what we specified in the previous pages, the perpetual pavement contains 3 layers to make sure that pavement can last for a longer time. The first one is a rot-resistant, impermeable, and wear-resistant top layer. Second one is a rot-resistant and durable middle layer. And we have the third one, fatigue-resistant and durable bottom layer. In summary, a perpetual pavement is a multi-layer design consisting of 3 asphalt layers. First, a renewable impermeable surface layer. Second, a strong, rot-resistant and durable intermediate layer, and a flexible, fatigue-resistant bottom layer. There are actually a lot of advantages about perpetual pavement. First, obviously, the pavement is durable and can last for longer time. It's designed to work for more than 50 years. And second, the pavement can experience less fatigue, cracking, and rotting based on the design of the 3 layers. Third, with the periodical replacement of the pavement surface, the pavement can be always smooth, so that the drivers on the road can experience safe and smoother rides. And actually, from the survey, we can find that the drivers prefer to see the pavement to be maintained periodically, so that you can gain better driving experience. In addition, perpetual pavement does not need any major reconstruction during 50 years or longer, and the cost will be much smaller. Also, as the replacement of the surface is easy and fast, it has minimum impact to the traffic on the road. Also, the drawback of this kind of pavement is obvious. It requires a much higher initial cost compared with the conventional pavement, which has the depth about the asphalt concrete around 150 millimeters or less. For perpetual pavement, the thickness of asphalt concrete will be 250 to 350 millimeters, which is almost double of the thickness in conventional pavement. In Ontario, the Ministry of Transport in Ontario (MTO) constructed its first perpetual pavement in 2007. The pavement is applied on Highway 406, and a trail section is applied with the perpetual pavement, and a control section is also designed with the conventional deep strength pavement. For these 2 designs, the total depth of the asphalt concrete in conventional pavement is 200 millimeters, and it's 250 millimeters for perpetual pavement. In 2016, after 9 years service, the performance of the pavement for these 2 designs are compared, including the pavement roughness, rotting, and cracking. If you are interested, you can try searching online about the comparison result. I will not introduce more details in this lecture. So that will be all about lecture today, and please go back to check the note in Avenue to Learn. And in the next lecture, I will try to finish the other types of the pavement. So that's all.